In this project, we are going to simulate an Ogee spillway using ANSYS Fluent. The main task of this type of a structure, i.e. a spillway, is to remove excess water in situations such as floods that water flow damages the dam body. The structure of these spillways consists of a vertical plate in the flow direction of the fluid whose upper edge can be both sharp, curved, and wide. Spillways have several types, including open channel, chute, stepped, bell-mouthed, siphoned, ogee, side channel, labyrinth, and so on. The present problem is an Ogee Spillway CFD simulation. Since the channel uses two different flows, the two-phase flow model is used. The two-phase VOF model is used in this simulation so that the water is defined as the primary phase and the air is defined as the secondary phase. The purpose of the present study is to investigate the behavior of water flow after passing through an Ogee spillway in the presence of airflow. The 2D geometry of the present model is designed by Design Modeler software. The present model involves a wide-angle overflow that comprises a vertical wall in the flow path. Also, the meshing of the present project is carried out using ANSYS meshing software and the mesh type is unstructured. The element number is equal to 10,959. Now the first step for you to start the simulation is to click on a fluid flow block and then drag it over a blank space in ANSYS Workbench software. Next, right-click on Mesh and then go over Import Mesh File. Then click on Browse and then select the mesh file that is sent to you with the rest of the files. Now there are several assumptions in this project. First, the type of our solver is set to be pressure-based since we are dealing with incompressible flows. Second, we have selected the absolute format for velocity formulation. And third, we have selected a steady time study since we didn't want our results to be a function of time. Also, as you can see here, we have selected the planar 2D space since our model is in 2 dimensions. And the next thing is that we have enabled the gravity and its value is equal to minus 9.81 in y direction. Now to model the two phases of air and water, we have to expand the models and then underneath it double click on the multiphase button. In the appeared window under the model section you can see that we have selected the volume of fluid method to simulate our two phases of air and water. Also under the body force formulation you can see that we have enabled the implicit body force to take into account the effect of gravity over our model. The next point is that under the options we have selected the sharp type of interface modeling since there is a distinct interface between the two phases of air and water inside our project. Next, if you click on the Phases tab, under the Phases section you can see that the two phases of air and water are defined here. Now in order to add another phase you can simply click on Add Phase button, and if you had previously added the material related to that phase in the Materials section, you can add that material as a phase here. Adding a new material will be explained in next slides. After double-clicking on the Viscose button, a new window will appear. In the appeared window, you will see that we have chosen two equations, standard K epsilon, to solve for our fluid flow. The standard K epsilon model is one of the most renowned models for solving the turbulent fluid flows, and actually two equation K epsilon model allows the determination of both a turbulent length scale and time scale by solving two separate transport equations. Also, you can see here that under the near wall treatment we have selected the standard wall functions, which are a type of auxiliary functions that help us capture and model the boundary layer and flow patterns near the wall accurately. Now, in order to add a new material, expand the materials and then underneath it expand the fluid. Then right click on fluid and then select new. In the appeared window, you either can define a new material by defining its properties yourself, or you can simply click on Fluent Database and select your desired material from the list of available materials in the Fluent software. Now in the next step, if you double click on the boundary conditions in the middle part of the software window, under the zone section, click on air inlet, and then you will see the type of this boundary is defined as pressure inlet. By clicking on edit button, you can adjust the settings related to this boundary. In this window, under the phase section, change it from mixture to air or water. For example, as you can see, if you change it from mixture to water, you can see the volume fraction related to the water phase is set as 0 since this boundary is related to the air. Next, if you click on the water inlet, you can see the type of this boundary is defined as mass flow inlet. Again, by clicking on edit button, you can change the settings related to this boundary. Now, just like the previous boundary, change the phase section from mixture to air or water. For example, if you change it to air, you can see the mass flow rate of the air phase defined over this boundary, which is related to the water phase, is set as 0. Of course, if you change it to water, you can see the mass flow rate of the water is defined as 376 kilograms per second. Now for the next boundary, which is the outlet boundary, if you click on it, you will see the type of this boundary is defined as pressure outlet. After clicking on edit button and the appearance of the new window, the most important point you should pay attention to in this window is the gauge pressure, which has the value of 0 Pascal, meaning that our mixture will exit our computational domain to the atmosphere. And finally, if you click on each of the vol boundaries and then click on edit button, in the appeared window you will see a stationary vol motion along with no sleep shear condition are defined. After double-clicking on the method, you will see that a new window will appear showing you the pressure-velocity coupling. Also, you can see that the spatial discretization methods are shown in this window. Also, you can change this discretization into other formats, like you can change them into first-order event and the other options available for each variable under their combo list. And for the simple pressure velocity coupling, the simple algorithm is kind of an iterative solver which uses a relationship between velocity and pressure corrections to enforce mass conservation and to obtain the pressure field. After double-clicking on the Controls button, in the middle section of the software window, you can see that new part will appear. In the Appear part, you can see under relaxation factors for different parameters. Now these values are set here by the software automatically. You can change these values, which are between 0 and 1, by yourself for different projects you do. But it is highly recommended that you do not do that, since it may result in divergence. There are two ways to check that your simulation process have reached convergence or not. Alongside checking the residuals reaching and nearing 0, you may define an arbitrary report or arbitrary boundary in order to calculate different parameters like pressure, velocity, temperature, and see whether they reach a constant value or not. If yes, it may be a sign that your simulation process have reached convergence. However, you must check the residuals as well. To create such report, you can simply right-click on Report Definitions, go over New, and select one of the options available based on your simulation. After double-clicking on the Residuals button, a new window will appear. In the Appear window, you can see the absolute criteria for equations like continuity, x velocity, y velocity, and so on. Now, when you set the software to start the simulation, there would be error between each iteration. Now, if that error is less than this criterion, it conveys the meaning that that equation has reached convergence. After double-clicking on the Initialization button, a new window will appear showing you different methods of initialization, hybrid and standard. Now in the standard initialization method, you get to choose the first amounts and values for the first iteration of the simulation progress. These values refers to the values used in the first iteration of the simulation progress, and if you choose the values for each parameter wisely, your simulation progress will
finish sooner. It should be mentioned that you can also choose the first values or the initial values by just clicking on the compute from drop-down list and clicking on one boundary. For example, by clicking on compute from all zones, the software will automatically average the values in different zones and boundaries and put those values in the initial values for the software.
After the process of initialization, we double-click on the Run Calculations button, and in the appeared bar under the Parameters section, we enter the value of number of iteration, as you can see in this slide, and then click on Calculate button. Now, in order to extract the graphical data, just expand the graphics, go over Contours, right-click on it, and then select New. Now, in this part, under the Contours of section, you can select your desired variable to extract its graphical data. For example, we select pressure as our variable of interest. And then simply by clicking on Save or Display button, the software will show us the graphical data or contours of pressure. Now in this slide you can see the pressure contour. Also you can see that behind the Ogee wall, due to the existence of a column of water, we have the hydrodynamic pressure. You can simply extract another contours related to other variables by simply changing the contours of section. For example, by changing it from pressure to velocity. And now in this slide you can see the velocity contours inside our model. Also you can see that the water phase has gained velocity while passing over the Ogee Spillway. And for the final results, in order to calculate the volume fractions related to two phases of air and water, you can simply change the contours of from velocity, for example, to phases. After changing the contours of to phases, make sure that underneath it volume fractions is selected, and then under the phase section you can select between the two phases of air and water. And finally in this slide you can see the volume fraction contours related to the water phase. Finally, a summary of the settings and setup that we have used in our project is presented in this slide. To benefit from Mr. CFD services including simulation, consultation, and training, contact our experts via info@mrcfd.com.